it's improbable that the electrical boxes are illegal because of box fill. The National Electrical Code, or NEC, doesn't have specific restrictions on box dimensions like the ones described. Similar products with comparable sizes are available. Several reasons could explain the difficulty finding those boxes. Firstly, limited production or availability might exist. A specific company manufactures them for a precise purpose, limiting production. Secondly, discontinued production might be the case. The original manufacturer may have stopped production and stock is lower. Thirdly, it could be a custom-made product specifically for a particular project, meaning it is not available through standard retail. If the exact box is not available, consider alternatives meeting NEC requirements for the application. A larger box with a blank cover plate or a surface mount box are alternative examples. Always consult a qualified electrician before installing electrical equipment. This ensures compliance with codes and safety standards. Let's delve into the concept of box fill calculations and the relevant sections of the National Electrical Code, or NEC, that govern this aspect of electrical installations. Box fill calculations are crucial to ensure the safe and proper installation of electrical conductors within enclosures. Overfilling electrical boxes can lead to overheating, insulation damage, and potentially hazardous conditions. The NEC provides detailed guidelines and formulas to determine the maximum number of conductors and devices that can be installed in a specific size of electrical box. These guidelines are primarily found in Article 314 of the NEC, which covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handle enclosures. Several factors influence the box fill calculation, including the size of the conductors, the number of conductors, the presence of devices such as switches or receptacles, and the volume of the box itself. The first step in performing a box fill calculation is to determine the volume of the electrical box. This information is typically stamped on the box itself or can be found in manufacturers' catalogs. The volume is usually expressed in cubic inches. Next, you need to count the number of conductors that will be entering the box. This includes all conductors such as hot, neutral, and ground wires. Each conductor is counted as one conductor equivalent, with some exceptions for short equipment grounding conductors. According to NEC 314.16, each conductor that originates outside the box and terminates or is spliced within the box is counted. Conductors that run entirely through the box without a termination or splice are generally not counted. However, if the conductors are unbroken and pass through the box and extend out the back of the box, each conductor is counted as one conductor. If the conductors enter and exit from the same opening, it only counts as one conductor. Conductor size and fill calculations in general, each conductor counts as one. However, different size conductors take up different amounts of space. NEC 314.16 details the volume allowance based on conductor size. For example, a number 14 American wire gauge conductor requires 2 cubic inches, a number 12 American wire gauge conductor requires 2.25 cubic inches, a number 10 American wire gauge conductor requires 2.5 cubic inches, a number 8 American wire gauge conductor requires 3 cubic inches, and a number 6 American wire gauge conductor requires 5 cubic inches. Device fill allowance devices such as switches, receptacles, and other equipment installed in the box also contribute to the box fill calculation. Each device is counted as 2 conductor equivalents based on the largest conductor connected to the device. For example, if a switch is connected to number 12 American wire gauge conductors, it is counted as 2 times 2.25 cubic inches, which equals 4.5 cubic inches. Internal cable clamps. If the box contains internal cable clamps, these also need to be accounted for in the box fill calculation. The NEC requires that 1 conductor equivalent be added to the calculation for all boxes with internal cable clamps. This is regardless of the number of cable clamps present. Equipment grounding conductors. Equipment grounding conductors that enter the box are also included in the box fill calculation. The NEC allows for a single deduction for all equipment grounding conductors entering the box based on the largest equipment grounding conductor present. This is covered in NEC 314.16b5. For example, if the largest equipment grounding conductor is a number 12 American wire gauge conductor, then 2.25 cubic inches is added to the calculation. Procedure for calculating box fill: calculate the volume of the box in cubic inches. Determine the number and size of all conductors entering the box. Determine the number of devices installed in the box. Add the appropriate conductor equivalents for each device. Add one conductor equivalent for internal cable clamps, if present. Add the volume allowance for the equipment grounding conductors. Sum all the conductor equivalents and compare the total to the box volume. The total conductor equivalent volume must not exceed the box volume. Practical examples of box fill calculations: consider a standard 4-inch by 1.5-inch square metal box with a volume of 21 cubic inches. The box contains 6 number 12 American wire gauge conductors, one switch connected with number 12 American wire gauge wire, and internal cable clamps. Calculate the box fill as follows. Firstly, 6 number 12 American wire gauge conductors equals 6 multiplied by 2.25 cubic inches, which equals 13.5 cubic inches. Secondly, 1 switch equals 2 multiplied by 2.25 cubic inches, which equals 4.5 cubic inches. Thirdly, internal cable clamps equal 1 multiplied by 2.25 cubic inches, which equals 2.25 cubic inches. Fourthly, equipment grounding conductors are 2.25 cubic inches. The total box fill is 13.5 plus 4.5 plus 2.25 plus 2.25, which equals 22.5 cubic inches. In this case, the box is overfilled since 22.5 cubic inches is greater than the box volume of 21 cubic inches. This situation requires a larger box or a reduction in the number of conductors or devices. Common mistakes in box fill calculations. Several common mistakes can occur when performing box fill calculations. One common mistake is failing to account for all conductors entering the box. This includes conductors that are spliced or terminated within the box. Another mistake is incorrectly calculating the conductor equivalents for devices. Each device must be counted as 2 conductor equivalents, based on the largest conductor connected to the device. Another common mistake is failing to add the appropriate conductor equivalent for internal cable clamps, if present. Accurate box fill calculations are essential for ensuring the safety and compliance of electrical installations. Adhering to the NEC guidelines and avoiding common mistakes will help prevent overfilling electrical boxes and potential hazards. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about box fill calculations or other aspects of electrical installations. Now let's explore some factors to consider when selecting electrical boxes for specific applications. The selection of the appropriate electrical box is crucial for ensuring the safety, functionality, and compliance of electrical installations. Several factors should be considered when choosing electrical boxes, including the type of wiring method used, the number and size of conductors, the environment in which the box will be installed, and the type of devices that will be housed in the box. Wiring method. The type of wiring method used in an electrical installation can significantly impact the choice of electrical box. Different wiring methods, such as non-metallic sheath cable, metallic conduit, and armored cable, require different types of boxes and fittings. For example, non-metallic sheath cable typically requires non-metallic boxes or metallic boxes with cable clamps suitable for non-metallic cable. Metallic conduit, on the other hand, requires metallic boxes with threaded or set screw connectors. Number and size of conductors. The number and size of conductors that will be entering the box are also important considerations when selecting electrical boxes. The box must be large enough to accommodate all the conductors and any devices that will be installed in the box. As discussed earlier, box fill calculations are essential for determining the appropriate size of the box. Environment. The environment in which the electrical box will be installed can also influence the choice of box. For example, boxes installed in wet or damp locations must be listed for wet locations and must be constructed of materials that are resistant to corrosion. Boxes installed in hazardous locations, such as areas with flammable gases or dust, must be explosion-proof and listed for use in those specific hazardous locations. Device type: the type of devices that will be housed in the electrical box, such as switches, receptacles, or lighting fixtures, can also affect the choice of box. Some devices may require specific types of boxes or mounting hardware. For example, heavy lighting fixtures may require boxes that are designed to support the weight of the fixture. Box materials: electrical boxes are available in a variety of materials, including metal, plastic, and fiberglass. Each material has its own advantages and disadvantages. Metal boxes are typically more durable and can provide better grounding than plastic boxes. However, metal boxes can also be more expensive and may be susceptible to corrosion in certain environments. Plastic boxes are less expensive and are resistant to corrosion. However, plastic boxes may not be as durable as metal boxes and may not provide as good of grounding. Box shapes and sizes: electrical boxes are available in a variety of shapes and sizes to accommodate different wiring configurations and device types. Common box shapes include square, rectangular, and round boxes. The size of the box is typically determined by the number and size of conductors and devices that will be housed in the box. Box mounting methods: electrical boxes can be mounted in a variety of ways depending on the application. Common mounting methods include surface mounting, flush mounting, and recess mounting. Surface mount boxes are mounted directly to a wall or ceiling. Flush mount boxes are installed within a wall or ceiling, with the front of the box flush with the surface. Recess mount boxes are installed within a wall or ceiling, with the front of the box recessed behind the surface. Standards and codes: electrical boxes must comply with various standards and codes, such as the National Electrical Code, or NEC, and Underwriters Laboratories, or ALL. These standards and codes ensure that the boxes are safe and suitable for their intended use. Selecting the appropriate electrical box is essential for ensuring the safety, functionality, and compliance of electrical installations. Careful consideration of the factors discussed above will help ensure that the correct box is chosen for each application. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about selecting electrical boxes or other aspects of electrical installations. In addition to the factors already discussed, there are some other considerations to keep in mind when selecting electrical boxes. These include the accessibility of the box, the aesthetics of the installation, and the cost of the box. Accessibility: the accessibility of the electrical box is an important consideration, especially for boxes that will be used for maintenance or repairs. The box should be located in a place where it can be easily accessed without having to remove or disassemble other components. Aesthetics: the aesthetics of the electrical installation may also be a consideration, especially in residential or commercial settings. The box should be chosen to blend in with the surrounding environment and should not be an eyesore. The cost of the electrical box is also a factor to consider. While it is important to choose a box that is safe and suitable for the application, it is also important to stay within budget. There are many different brands and types of electrical boxes available, so it is possible to find a box that meets your needs and budget. Additional tips: here are some additional tips for selecting electrical boxes. Firstly, always read and follow the manufacturer's instructions for installing electrical boxes. Secondly, use the correct type of connectors and fittings for the wiring method being used. Thirdly, ensure that all boxes are properly grounded. Fourthly, do not overfill electrical boxes. Fifthly, protect electrical boxes from physical damage. Selecting electrical boxes is a critical aspect of electrical installations. By carefully considering the factors discussed above and following the tips provided, you can ensure that you choose the right box for each application. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about selecting electrical boxes or other aspects of electrical installations.